Hi, so in this video I'd like to talk about the flake8 library. So first of all, the project with this README here is included in the GitHub repo that's linked below the video. So when you run this, you should treat this as an independent project. It has its own requirements.txt file if you're using pip, or it has a corresponding pip file if you're using pipenv. So flake8 is a tool for Python style enforcement according to conventions generally agreed upon by Python developers worldwide. And typically you'll definitely use them when you're working in a team environment with multiple developers working on the same repository. But it's really more than just style. It can also help you find bugs in your code, possible security issues, bad design, etc. And flake8 is a base system, but it also has a ton of additional plugins that you can then leverage to check other things in your code. So in this project, we're going to essentially implement black and ISO, just like we did before, and we're going to add flake8. Now, when you run flake8, you get violations or warnings, however you want to call it, that get reported. And these are generally numbers with some letter prefix. For example, F401, E201, etc. And in general, every plugin, whether it's built into the flake8 that gets installed or added in as an additional plugin, has its own unique character prefix. And so you can tell which, essentially, which plugin is generating that particular warning or violation. So by default, flake8 includes 3 plugins. It has PyCode Style, which is largely PEP8 related, PyFlakes, and the McCabe checker. So I have links over here to each of those. For example, we can take a look at PyCode Style. And so, for example, you can see things like error codes here. And here you can see those codes I was talking about. Like, for example, E111, indentation is not a multiple of 4. Then you get things like, for example, whitespace, having a whitespace after a parentheses. In Python typical styling, you don't do that, and so on. So it has a bunch of stuff, as you can see, that it can catch. Number of blank lines between functions or between methods in classes, and so on. You can also you'll see things like multiple imports on one line, or the module level import is not at the top of the file. Your import should always be at the top of the file, and so on. So again, these are basically PEP8 things. I know some of you have told me in the comments that you object to PEP8. That's your problem. If you don't want to respect PEP8, that's up to you. There's nothing that forces you to do so. However, when you're working in a team environment, you're likely to find that they are sticking to that convention. A lot of very intelligent people have worked on the PEP8 standards over many years. And personally, I happen to like it, and I happen to follow it. I don't always like everything that's in there, but in general, I follow it. Of course, sometimes you have to break conventions, and that's fine too. But you should be breaking conventions thinking about it, right? There's got to be a definite reason why you want to break a certain convention. So flake8, and in particular, this plugin here, this PyCode Style, is going to help you fix and identify some of those problems. Then it has also PyFlakes, it's going to catch things like unused imports. You may have an import in a module that's left over from when you were doing something and you forgot to remove it because you don't need it anymore. This is going to find it. If you've got duplicate function arguments, for example, then you may not realize that as you're developing your code. This will catch it as well. And then you have the McCabe thing. Now, McCabe is a little bit more controversial. Some people like it, some people don't. I typically tend to leave it enabled. It's basically a complexity measure of your code. And you can read more about it. It's a pretty tough read. It's called the McCabe cyclomatic complexity. But basically, just think of it this way. If you write a function that has a ton of nested if statements and for loops and everything, it can become kind of difficult to understand, right? It's complex. And so this McCabe complexity measure gives a numerical value to that. And with the McCabe enable, which is the default with flake8, it will warn you if it goes over a certain complexity. And this typically means that you need to break your function down into smaller chunks. You need to use decomposition. So instead of having a single function with, 100 lines of very convoluted and nested code, which is what increases the complexity. It's got nothing to do with readability. It's really about the complexity of the code. It basically is telling you, break this function up. Make smaller functions that have, a single purpose in mind, and then assemble them together, compose them back into your main function. So those are the ones that come standard with PyFlake. What we're going to do as well is I'm going to add in a series of additional plugins that I use frequently in my projects. Generally, I use almost all of those in all of my projects, and there might be some additional ones, or sometimes I may drop one or two, depending on the project. So you have to ask yourself, what do I really want for this project? What do I not want? Okay, so just think about that and make a decision, an informed decision as to what you want to do. So some of the ones that I add, I like Bugbear. If we take a look, all these are linked, by the way. So if you go to the README file, you'll find the links for each of those. So if we go to Bugbear, this is the actual GitHub repo for Bugbear, and where you have the documentation. It tells you how to install it. And then it also gives you the list of warnings. Like, for example, B001, do not use a bare except. You shouldn't be using a bare except in Python. You should be using an except exception if you want to be really broad. And I also don't recommend doing that either. I recommend trying to make exceptions as specific as possible. But if you do want a bare except, essentially, then you should use the base exception. Basically, this is forcing you to make a deliberate choice of what you want to catch in your tries. And this is things that can help you, for example, resolve bugs or unintended flows in your application. Or for example, this one, B005. As you can see, we've got the prefix and a character code. And so the strip here, if you use with multiple characters, well, that could be misleading. You may be tempted to think that if I have strip and then I've got a string ABC, it's going to strip ABC, the particular sequence ABC, from the beginning and end of whatever you're stripping. That's not the case though, right? It's going to strip any A, any B, or any C, right? That happens. So that's a little bit different. So this could be a bug. And so this basically warns you that, hey, if you're using a strip of multiple characters, be careful with that. And of course, you can always go into your code and say, no, ignore this error, B005. I know what I'm doing. Don't do it. I'll show you how to do that later. So basically, Bugbear has a ton of stuff. For example, if you're using set attribute, X attribute value, it will tell you that why don't you just use this instead, right? There is no additional safety in using set attribute if you know the attribute name ahead of time, right? Which is exactly what this is here. It's a constant string. You know what the attribute is. There's no reason to use set attribute. So again, this isn't a bug in your code. It's just basically helping you write better Python code. Now this one's an interesting one. For example, B14, right? This is redundant. If you do an except and then you trap two exceptions here, one of which is exception and the other one is type error, well, type error is a subclass of exception. So if you're catching exception, it's going to catch type error anyways. So this basically tells you, hey, this is redundant. Again, it's helping you write better Python code. And as you can see, it's not really style related, this, right? It's just something that doesn't make sense. And so on. You can see it has a bunch of things. So I use Bugbear all the time. Flake8 comprehensions helps you improve your comprehension code. If we take a look at that documentation here, you'll see it has things like rewrite this. If you've got an expression like this, list, and then fx for x in foo, so basically this is a generator expression, and then you put a list around it, well, you can just use the square brackets notation, and so on. You also have things where it can catch unnecessary list comprehensions. You can take a look at all that, or for example, things like you might be writing something like this. Well, if it's literal, you can just rewrite it as the literal, and so on. So it's got a bunch of things that helps you improve the code that you have for comprehensions. Then I also use the flake8 implicit string concat, and this one I really use because I also use black. So black can introduce weirdness. If you take a look at this code snippet over here, right, we wrote basically this string using multiple lines. So this is kind of what's called implicit concatenation, and it's inside the parentheses. So we can actually split that over multiple lines. And very often that's useful when you're trying to build up a string that is, longer than your line limit essentially in your editor. Because remember, with black, we set a line length. Here in my project, I've got that in the PyProject TOML file for black. I've set my line length limit to 80. And this is relatively small. And now I do that simply because I'm, running a bigger font, etc. for these videos. In practice, I use a slightly larger number, like 120. But it will depend on the team you're working with. So what happens when black sees this, it looks at this string and it says, well, it will actually fit over 80 characters. So it goes ahead and rewrites your code this way. And as you can see, what it does, it leaves the implicit string concatenation in place. Now, I don't like that. I would rather then see this as this is a string literal that would fit on a single line, and then the final double quote, not have these double quotes in the middle. And so this is what implicit string concat will do for you. It will basically catch those weird things that black will sometimes do. And if you don't always check what changes black has made, you might miss something like this. So again, this is just styling, code cleanup. Then you've got the flake8 naming. This is for naming conventions. Again, there's the link to it. And this is for naming conventions for your functions, your classes, your arguments, things like that. You've also used flake8 built-ins. It makes sure this one that you don't accidentally use a Python built-in for variable or parameter names. It's very easy to make a mistake and to shadow a built-in function or a built-in attribute of Python to redefine it, because now you've assigned it to that particular label in your code, and now you have potentially a bug. So this will help you make sure that you don't do things like that. Now, Bandit is interesting. Bandit is something that I use relatively often when I'm running things, especially locally. It basically can find security issues in your Python code. So for example, if you're writing SQL statements that you're then executing against a SQL database, and if you're interpolating data into it using like F strings and so on, you're potentially opening up yourself to SQL injection attacks. And Bandit will actually catch those kinds of things. Now, with Bandit, it's maybe not necessary to run, because very often in CI/CD pipelines, in team environments, you usually have other applications, other tool sets that are used to do security checks on your code, in which case you don't need to run Bandit. If I don't have that in place, then I'll like to run Bandit simply because it helps me a little bit. It doesn't catch everything. It's probably not as good maybe as some of the other tool sets that are out there, but it's still good enough for me when I don't have anything else to use. Flake8 Eradicate and Flake8 Print are another two that I use, and I always use Git, so I'm always using version control. So if I make a change to my code, I don't need to comment out a piece of code to make sure that I don't lose the history, or I might want to go back to it in the future, so I want to keep it there commented out. In terms of reading code, when other people are reading your code, that's bad practice, because now you got a ton of these pieces of commented out code that people have to scroll past and ignore. If you're using version control, you don't need it, right? Because you're doing your commits, you're retaining your history. So if you need to go back and look at what code looked like a while back, well, you use your commit history to do that. So Eradicate is basically going to look for any piece of commented out code and warn you about that. In the same vein, I also use Flake8 Print, because print is going to tell me if I've got any print statements in my code. Typically, when you have production code, you don't have print statements, right? You're not printing to the console because nobody's interacting with the console. So maybe you need to use logging instead. That's one thing. So why print? Well, I often use print when I'm debugging my applications locally. So I might put some print statements here and there. Of course, I use the debugger as well, but print statements can be pretty useful as things are running. But I want to make sure that before I check in my code to say, hey, I'm done. So before I do a merge into whatever repository I'm using, I want to make sure that I've removed all those print statements. And that's what Flake8 Print will do. So the other thing too is the violation codes. So I've already explained that the violation codes, when you run Flake8, it's going to give you a report and saying, hey, you've got this problem, E001, W220, or whatever it is, right? And so you get these codes, and if you need to know what the codes list are, I have them all listed here. So for example, PyCode style is going to report under E something or W something. PyFlakes will be F something. McCabe only has one, it's C901. You can look at the full codes list over here for the built-in flake8. So you can see all the codes that are here. Then we've got the same thing for the built-ins. Now the flake8 built-ins doesn't actually have documentation for the codes. So I went and looked at the source code, which is located here. And if you take a look at the source code, you'll see what the particular things can be. So you have A001, A002, A003, right, as the things. And you can see A001 is for a variable that's shadowing a Python built-in. A2 is for an argument of a function that's shadowing a Python built-in. And A3 is for a class attribute that's shadowing a Python built-in. So I should add that here. Okay, then flake8 bugbear, you can find the codes list there and so on. So basically you have all these links in the README. Now there are other plugins. As I said, there are many other plugins for flake8. There's this repo over here that I found that has a whole list of flake8 extensions, flake8 plugins that you can use. So as you can see, there's not a lack of choice. However, I would caution you before using any of those is to take a look at, are they relatively popular? And B, are they still being actively developed? You really want to stay away from Python libraries, third-party libraries that are not being actively developed anymore because they usually do have bugs and no one's going to fix them. So then you're on your own. You're going to have to fix the thing yourself. You're probably going to have to fork the library and then make the bug fixes yourself. So I try to avoid that as much as possible. So I tend to stick with popular and actively developed plugins for flake8, and actually in general for third-party libraries for Python. So to install, we have to install flake8, and then we also have to install flake8 bugbear, flake8 comprehensions, and so on. So you'll see that that's exactly what I have in the requirements.txt file. If you're using pip to pip install, pip install -r requirements.txt, you can do that. Or if you're using pipenv, then I have that in the pip file as well. You can see that it's all here. Now you'll notice that I have it in terms of the pip file. I have it into the dev section. And that's because I never use those things when I'm running the code in production. So my packages would be what I need to run the code in production. But this is what I need to basically run my code locally with Black and isort and flake8 and whatever else. So this is fairly typical if you're using pipenv to split it up this way. Okay, so just like before, we're going to have to configure Black and isort, and it's actually pretty straightforward. We have this PyProject toml file, and as you can see, I've got my line length for Black, and then I also tell isort that I'm using Black, and this helps avoid some of the problems that we face sometimes, the clashes between Black and isort. The other thing that we need to do is we need to configure flake8. So we don't do the configuration in the PyProject toml file. flake8 doesn't support that. So instead what I do is I use a .flake8 file, which is this one over here. And here's the section for flake8. And you can see that I set my max line length to 80, so I kind of match what I have on Black. This is my complexity level. I think the default complexity level might be 10. I set it to 11. You can set it higher if you want, but again, make a conscious, informed decision of why you're doing that. Okay? And then we have these, so by default, these things, all these plugins are going to run, but there are some things that I may want to ignore. For example, I want to ignore B901, which is return statements in generators, because in Python 3, that's allowed. What's E203? I didn't fill that out, but you can go ahead and take a look and basically do a search if you want for E203. So let's look at this. Let's look at Python E203. So it's a white space before the colon. So why do I exclude E203? Well, that's because it causes problems with slices. And if you actually look at the PEP8 recommendation for how you write slices out, so you may have things like, some list, let's say, and then from 1 to 3. Well, there is no space right around these, and that's perfectly fine from a flake8 perspective. You may do things like this, for example, where you have L1 space 3. Now this won't trigger the E203, and that's perfectly fine according to flake8 as well, but this is not. So anyway, this is why I remove E203. And you can go ahead and take a look at the other ones, E226, 302, and so on, see what they are and see if you want to keep that or not. So here, the extended ignore means that PyFlake, or flake8 I should say, has a basic set of already ignored rules, and this extends them. You could also specify ignore, in which case it's going to replace the ignores that are currently in place and not extend them. It's going to replace them with these. Here I want to do an extended ignore. And you can also do include and extended include as well if you need to. And most of these are automatically included if they get installed. Depending on the particular plugin you're using, you may have to do an extended include in here, and that's going to be up to that particular thing. All right, so this has been a lot of talk about the setup, what flake8 is, what are the different things that we're using, time to actually use it. It's very, very simple to use, and we basically just call flake8, and we can either call flake8, which will do the entire current directory and subdirectories, or you could direct it to a specific file, okay? Like say flake8 just badcode.py. You can also specify multiple files. You can also specify paths, and then we'll look recursively under those paths. So let's go ahead and let's start by running Flake. So I've got this bad code, and I'm going to copy this bad code that's in badcode.bak, and I'm going to put it in badcode.py. Like this, we start with the same thing. And as you can see, even my IDE is giving me errors, right? It's telling me all about this stuff. So let me get rid of these things, and you can see I've got these two imports that my IDE is telling me, hey, you're not using them. I've got these bad naming conventions for my functions and for my arguments. And then you can see I've got a bare except over here. Even my IDE is telling me about that, okay? But there's a bunch of other things as well that my IDE is not telling me. So let's go ahead and run this on that particular thing. So let's go ahead, and I'm going to say flake8, and I'm going to take the current directory and say badcode.py. So I'm going to run it like this on just this single file. And let's see what we get. So as you can see, we have a bunch of errors. We have a bunch of these violations, F401, N802, B006, etc. So I could certainly start going through those one by one and trying to fix them. But this is where isort and black come into play. I'm going to first go ahead and run black. So as you can see, I've got it in the README file. This is what I'm going to do. So I'm going to say black, and then we'll say badcode.py. That's going to fix up some of the issues. Okay, so it reformatted, and there were some changes. Next, I'm also going to run isort. So that way it's going to fix any kind of issues in the order of my imports. So we'll run that. So that's fixed. And now finally, I'm going to run the flake8 again. It will have removed some of the issues automatically for me. And I don't know if it did or not, but that's typically the workflow that I follow. I run black, run isort, and then I run flake8. And if you're on Linux or a Mac, you can actually write a make file to do all those things for you. I showed you how to do that with black and isort in the black and isort video, and you can certainly extend on that to add in flake8 as well. Okay, so now basically I have to go through all these things. So first one, CSV imported but unused. So what I like about PyCharm, these are clickable. It will take me straight to the line. So I can go ahead and remove those two. Now the problem when I remove those two lines is that this line now is going to be incorrect, okay? Because this is now saying that this line has a problem. So let's go back to this. Let's remove those two. And now if I click on this, you can see it's not taking me to the right location. So what I'm going to do is I'm going to run flake8 again. And actually I'll clear my terminal and run flake8. Okay, so now I'm going to basically work my way down. So make temp directory. Well, according to directions, that should be make temp directory. Now, I'm not just going to change the name here. I'm going to use the refactor that's in my IDE, because that will then change also the names of the places where I'm calling this function, if any. So I'm going to use make temp directory like so. I'm going to use camel casing and then refactor. Okay, so then we have argument name, dir name should be lowercase. Well, I'm right here. So again, I'm going to refactor this, and we're going to say dir underscore name. And you can see it refactored it inside my function. I can see that I have the argument file name should be lowercase. So now, yes, if I click on that, I'm not, well, actually, I didn't delete any lines, so I'm still good. So I'm going to refactor this as well. File underscore name. Then what's next? Well, I'm going to clear and rerun as I'm working my way through. So on line 14, it's telling me, do not use mutable data structures for argument defaults. They are created during function definition time. All calls to the function reuse this one instance of the data structure, persisting changes between them. Yes, that's a big no-no, right? You should never do something like this in Python, because you're going to potentially run into bugs. So instead, what you might do something is to say, well, the default is none, and then you might do here and say if types, if not types, or if types is none, because we actually want to check specifically for none. And then we'll make that an empty thing. So this is going to fix that problem. Okay, so let's go ahead and rerun this. Okay, so now we're on to our next bug, or next issue, I should say. Do not use a bare except. And yeah, if I'm doing an open file, there's no need for me to do a bare except. I could catch the specific exceptions that open might raise, or if I really want to be as broad as possible, I could just type except exception. Now, my IDE is still complaining that it's too broad, but PyFlakes is not configured that way, and it's no longer going to complain about it. But generally, again, this is not good Pythonic programming. You want to try and be as specific as you want in your exceptions. Otherwise, you might be handling things that you really didn't want to handle. You would rather get an error when your program runs and be aware of this issue. Okay, so the next one we have is this one. Loop control variable I is not used within the loop body on line 25. Well, yes, I is declared here, but it's never used. So a typical convention is to use an underscore, and you can use underscore I if you want to, or you can just simply use the underscore by itself. That's a valid variable name in Python. And the convention is that if something is ignored, we put the underscore in front of it, or we just use the underscore by itself. Okay, so that one's fixed. Let's move on to this one. Unnecessary generator. Well, look at what I have here. I have list, and then I've got a generator in here. Well, all I need to do is really just say the square bracket, like so. Okay, and then the square bracket to end. So this changes my comprehension this way. Okay, let's go ahead and run flake8 again. And let's see where we are now. So we're still on that same line, which is why I reran flake8. Standard pseudo-random number generators are not suitable for security and cryptographic purposes. And that's because I'm using random. So in this case, though, I'm looking at this and I'm saying, well, I'm not using this for security or cryptographic purposes. So this is actually okay. How do I tell PyFlakes, or flake8, I should say, ignore this thing? Well, what we do here, we put a comment at the end of the line. So 2 spaces, a comment symbol, and then we say no QA, colon, and then the code that we want to ignore, S311, like so. So let's go ahead now and run this again. And you can see that that has disappeared. So basically we've silenced this. We've intentionally said, I know that this is sometimes an issue. In this case, it's not. So you can go ahead and ignore this warning, this violation S311 on this line. Okay. So that's how you can basically silence certain warnings or violations in your code. Okay, so now we have the next one. This line is too long because of, I've got the 93 greater than 80 characters. Well, I could try and fix this by hand, but I'm not. What I'm going to do is I'm going to run black again now at this point. And if we look at what it did, you can see it reformatted the whole thing. So now that we've got that, let's go ahead and run flake8 again. Okay, and now we're back to this problem. What happened? Well, what happened is that the no QA applies to the line it's on. So now I need to move it over here. Okay, so now let's go ahead and run black again. And it reformatted things this way now because it's saying, well, it's too long, right? Because of my 80 character limit. Okay, so now this is going to be on the wrong line. So I'm going to move that over here like so. Okay, so you can see where sometimes you can run into little issues between black and flake8 and your length, your line limit, things like that. You just have to basically rewrite your code so that it's going to kind of match everything that you need. So let me go ahead and run black again. Okay, so one file left unchanged, so I was happy with that. And now let's go ahead and run flake8. And you can see it's no longer complaining about this random here. Okay, so on to the next one. Let's take a look at this one. Gilded rows update quality is too complex. It's got a complexity of 18. And you can see that there's a lot of if statements and all that kind of stuff, okay? And so I'm not going to do this here, but this is where you would want to go into your code and rewrite this, right? If you look at this code, I mean, I can't understand it, right? And anybody coming in looking at this, if they haven't actually written it, and even if you have written it, and maybe you're looking at this 6 months later, you're going to be wondering, what the heck is going on here? So this is kind of a standard problem. Actually, if you go into a Google search for gilded rows, you'll find blog articles on that. So I will let you deal with that. What I'm going to do for this thing is I'm going to just remove it. Okay, so I'm going to take that away and let it be like this. You can see I got a lot of spaces over here, which is too many. And this is why you can see my IDE complaining. So let me run flake8 again. And you can see it actually tells me I've got too many blank lines. So I can go ahead and remove them myself, or I could also use black. And black is going to reformat it. You can see it got rid of the spaces. So now if I run flake, you can see that that problem is gone. Okay, so now we're down to the last three. We've got this one, implicitly concatenated string literals on one line. How the heck did this happen? Well, let's go back and look at the bad code, which is why I wanted that in the first place. If you look, this is how I wrote it, right? I wrote it this way. Black is the one that changed it back to this, that said, no, it can fit on one line. And so now I get a warning that, hey, you've got this implicit string concatenation on the same line. That's not good style. And so, yes, indeed, what I'm going to do is I'm going to take spaces out like so and just clean my code up. So this is what that extra plugin that I was telling you about did here. It found a problem that black introduced into my code. Okay, so now that's done. Let's go ahead and run flake again. All's good. So typically I would run black. That's fine. I would run isort. That's ran. And then I would do the final one with flake, like so. All right, so that's flake8. And as you can see, it's very simple to use. You just have to basically decide what you want, and then you have to configure it. Are there any exceptions or violations you want to include or exclude specifically? You can do so. You can do that through the flake8 file, the configuration there. And then you can also set up your black and isort this way. And if you want, you could write a makefile to run all these commands every time for you, so you don't have to run black, then isort, then flake8 manually. Typically, that's what I have. I have a make command, which will, instead of me running, flake8 every time, then it will actually just do black, then isort, then flake8 every time. Okay? All right, that's it. Thanks for watching.